The Latin term for cloud, nebula, is where the English word nebula comes from. A nebula is a general term used to describe bright, hazy objects that are visible outside of our solar system in interstellar space. The term nebula has been applied to a wide range of items across time. These include certain diffuse galaxies, like Andromeda, which we now know is a galaxy, and comets, which to early astronomers frequently resembled space clouds. Galaxies were long thought to be spiral nebulae until about 1922, when astronomers realized they were a different phenomenon. Outside of the Milky Way, galaxies are significantly larger objects made of masses of stars. However, scientists now widely agree that nebulae are made up of enormous, primarily luminous clouds of interstellar dust and gases, like as hydrogen and helium, that are hundreds of light years across. Interstellar matter, or the gas between the stars that is usually always accompanied by solid grains of cosmic dust, is what makes up all of the observable nebulae in the Milky Way galaxy. Their appearance varies greatly depending on the temperature, density, and spatial arrangement of the material in relation to the observer, in addition to these other factors. The majority of their constituent atoms are hydrogen, which accounts for around 90% of them, and helium, which makes up almost all of the remaining atoms. The remaining atoms, which include oxygen, carbon, neon, nitrogen, and other elements, make up roughly 2% of all the atoms in the universe. Nebulae can be broadly categorized into two groups based on their appearance: dark nebulae and bright nebulae. Dark nebulae obscure the light of the stars that are located beyond them and appear as irregularly shaped black patches in the sky. Bright nebulae have blazing surfaces that are only dimly illuminated. They can emit their own light or reflect the light of neighboring stars. Dark nebulae are frigid, extremely thick molecular clouds that hold about half of the universe's stuff. The typical density of hydrogen molecules per cubic centimeter range from hundreds to millions or more. New stars are created in these clouds as a result of the gravitational collapse of some of their constituent pieces. The majority of the remaining gas is in the diffuse interstellar medium and is only visible by its radio emission of the 21 centimeters line of neutral hydrogen due to its extremely low density, approximately 0.1 hydrogen atom per cubic cm. These dense, opaque clouds contain H2 molecules as their source of hydrogen. The so-called enormous molecular clouds, the largest nebulae of this kind, are a million times more massive than the Sun. They are around 150 light-years across, comprise a large portion of the interstellar medium's mass, and have an average density of 100 to 300 molecules per cubic centimeter with an interior temperature of only 7 to 15 K. Although many stars are also present, molecular clouds are primarily made of gas and dust. Except for the far-infrared thermal emission from the dust grains and the microwave emissions from the constituent molecules, the inner portions of these clouds are completely obscured from vision by dust. Dust cannot absorb this radiation, therefore it rapidly leaves the cloud. On all size scales, the material within the clouds is tightly packed, with some clouds reaching as low as the masses of individual stars. The clusters can contain up to 105 H2 molecules per cubic centimeter of space or more. Small clusters could measure up to 1 light-year across. The interior magnetic field and turbulence act as a cushion against the gravitational pull of the clouds. An crucial process occurs in the inside of molecular clouds. Stars are created as a result of the gravitational collapse of dense clusters. The cloud initially consists of a disorganized collection of smaller clouds, each of which will eventually become a distinct star system. Because of the initial motions of the material that is falling into each system, it has a rotating motion. The collapsing cloud flattens as it contracts due to its rotation. At some point, the majority of its mass will be in a spinning condensation around its center, a protostar that will eventually become one or more nearby stars. A revolving disk that is bigger than the solar system and contains comets and protoplanets surrounds the protostar. Nebulae types. The majority of these phenomena fall into one of the following 4 or 5 categories: supernova, dark, emission, planetary, reflection, and emission. Dark. Because they are so dense, dark nebulae containing carbon, silicon, and a variety of other elements appear dark because they obstruct the light of the nearby stars. These tiny particles cannot be seen through a common telescope because they are covered in frozen nitrogen and carbon monoxide, which absorb visible light. They are only discernible in the infrared range as dark forms. These nebulae can still produce planets and other large astronomical objects even though they do not emit any light and instead develop into stellar nurseries. There is a dark spot in the Milky Way's Cygnus constellation that is known as a dark nebula. Other dark nebulae include the Great Rift and the Coalsack Nebula. Emission nebulae, in contrast, are enormous, ionized, fluorescent clouds of gas that glow in a variety of colors. The stars that are embedded within or occasionally behind them emit light that charges the nebula's gas and produces this magnificent glowing effect. The majority of the time, this happens when a nebula's gases condense into a hot, dense point. This ignites to shine brightly. These particular star formation regions, known as stellar nurseries, are connected to these kinds of nebulae. This type of emission nebula is well represented by the 20 light-year wide Orion Nebula, which is green in color. Stars are being born in this stellar nursery. The Eagle Nebula, made renowned by the amazing photos captured by the Hubble Space Telescope, is another well-known instance of an emission nebula. The enormous gas formations known as the Pillars of Creation are also found inside this particular object. One of the most amazing objects in the galaxy that has been seen so far is the Eagle Nebula, which is found in the Serpens constellation. Planetary. An emission nebula, or planetary nebula, is one that is made up of ionized gases that emit light rather than absorb it. When some stars progress past the red giant stage of their life cycles, planetary nebulae are created. Through a telescope, they seem round and greenish, like a planet. They now just have their cores remaining after shedding their outer atmospheric layers. White dwarfs is the name given to these remains. The remaining gas and dust from the white dwarf continue to radiate light, developing into a planetary nebula. They not only resemble planets in appearance, but also orbit their stars in a manner similar to planets. One illustration is the Ring Nebula, which has the appearance of a vibrant hot spring pool similar to those in Yellowstone National Park. Late in its life, an ancient red giant star released a brilliant disk of ionized plasma. Reflection. Reflection nebulae only reflect the light of nearby stars and other nebulae, in contrast to emission nebulae. The reason why these nebulae usually appear blue, like the sky, is essentially same. Only light at the blue end of the spectrum is scattered by the particles in these clouds. 900 light-years away in the Eridanus constellation, the Witch Head Nebula is an illustration of both a reflection nebula and a supernova remnant. When a supernova, one of the universe's most potent occurrences, spews matter hundreds of light-years in every direction, it leaves behind a remnant. The stunningly gorgeous Crab Nebula in the constellation of Taurus is another illustration of a supernova remnant. Supernova. When a supernova, one of the universe's most potent occurrences, spews matter hundreds of light-years in every direction, it leaves behind a remnant. The stunningly gorgeous Crab Nebula in the constellation of Taurus is another illustration of a supernova remnant. The size of nebulae. The majority of nebula are enormous, measuring thousands or even millions of light-years across. Nebulae typically cover thousands of billions of miles in space. For comparison, the Sun is around 865,000 miles across and the diameter of the Earth is slightly under 8,000 miles. Due to their size, even a modest nebula might easily swallow our entire solar system. Future nebula studies. Due to the development of space telescopes like Hubble, amazing images of these amazing interstellar structures have become available. We anticipate that the James Webb Telescope will broaden our understanding of where we fit within the cosmos. This is all for today. Don't forget to subscribe and click the bell icon for more videos. Stay tuned with AWZ.